Hello everyone, welcome back. So in this video we are going to understand the problem number 2 that we have seen yesterday, right? So it was problem number 1, but this is problem number 2 where we have to find the minimum pair removal to sort the array, right? So sort the array 1 we have already seen. The major difference between these two and the study one is we are able to do the problem solution with respect to greedy approach, not greedy approach, just simple approach you can say we are able to do, right? But this Leetcode problem look like a very simple greedy merge, but one wrong assumption that it will give you that it will fail on the large test cases. I'll show you why it is failing. So when you come to the constraint, right, this is why the your solution will fail, that the same code will work for you, that we have submitted yesterday. It will work for you, but the problem is that out of the 700 test cases, one test cases approximately it will fail, right? Means approximately 680 something will work, but 680 81 will not work, because that it will take a large input. Okay, because as we have given that this is a large input, we have given large test cases, we have included in this problem. So how you are going to solve this type of problem? Because we have already solved this problem yesterday, but there is little change with the high constraint, high test cases. So how will you fix it? The very first, try to understand the statement, right? Very first, what we have given is we have given an array, right? So we have given array as we have seen. So repeatedly you must merge the adjacent pair, right? It is saying must merge the adjacent pair with the minimum sum, we can say, right? So we have to find the minimum sum and then we have to merge it, right? So where we will find the minimum one, let's suppose the minimum is 31 and we are getting the value minimum sum is 4. So we have to, after the replacement, the array sum has been merged, these two element has been merged as a 4 right here. So the array become like this. Similarly we'll repeat like this. We will find the minimum sum and that we will merge this array, and when it become the non-decreasing, then we have to count the number of operations, how many times we have done the merging. That thing we have to return. So we have to return the minimum number of operations instead of to make the array non-decreasing. So that we already knows, right? So each merge replaces two numbers in their sum, right? And then it forms the new array, right? So our goal is to make the array non-decreasing using the minimum number of merges, and finally he will return that. Okay, so why the most solution fails here? Because the most people stop when the array looks sorted. That is wrong, because the minimum sum rule is global. It can force merges even after the array appears sorted, and this is cause classic off by one failure. Okay, so the real problem, or you can say the real cause, because the invariant is not whether the array is sorted. The real invariant is number of decreasing adjacent pair, right? So if there exists one inversion, the array is still invalid and we must keep merging that, right? We have to do that. Okay, so the correct strategy is what? The correct strategy is that we should have three parts. Very first is track how many adjacent inversion exists, right? Always merge the global minimum sum adjacent pair and then update the inversion count locally, not by rescanning the array. Okay, that we have to do. Understand? Means we have to track how many inversion exist, how many adjacent inversion exist in this array. Like this we have seen that we have seen that, right? So all the possibles we have to find. Then we always merge the globally minimum sum pair, like this we used to do, right? That we can do that, and we will update the inversion count locally by re-scanning the array. So we have to re-scan the array and then we have to do that. Okay, so very first, how we are going to use, we will use a doubly linked list to support O of 1 merges, and then we'll use priority queue to always pick the minimum sum pair, and there will be a lazy deletions to ignore stale heap entries. Okay, so let me show you. Okay, so as you can see, these test cases will work fine for you, but when we go for the big test cases, it will not work, guys. So for that, very first, what we have to do, so instead of checking if the array is sorted right, I track the number of decreasing adjacent pair, and each merge removes or create inversion locally, so which I will update in O of 1. So I always merge the globally minimum adjacent sum using the priority queue, and it will ignore the stale pair via lazy deletion. So once there are no inversion left, the array is guaranteed to be non-decreasing. So this is what we will do. So you should explain that how to explain this in interview. Like this, you will say this is my approach and that I am going to use, right? You have to tell. Let's come back to the code. The very first, let's go to the main method where we have to do. So this is what we have given. We have given a class, right? And the class we have is int sum. Int num we have given, and as I told you that we will use a doubly linked list to support O of 1 merges, right? So we'll use that, and we will also use priority queue that will pick the minimum sum pair, and then we'll use a lazy deletion to ignore the stale heap entries. So very first we should do the initialization. We will convert the array into linked list. So we know that how to do that. So as you can see that we will come on the what you call the loop, and then we'll do. Okay, but before that, very first you take the minimum heap to always extract the minimum adjacent pairs. So we'll call the min pair, and we have to take a pair candidate. So you have to define this class. As you can go here, this is a pair candidate, and how you will create the pair candidate, you have to create a list node. So create a list node, you know that we have to create the list node. So very first there will be a value, and there will be original index, and then we'll have the previous and the next, right? So the question is how we are going to define it. So we know that the value is the current value of this node, we can say. Original index is to stable identity for the lazy deletion, and there is a prefix node in the linked list, and the next node, that you know, right? And if we want to create the node, we know that we have value, the original index will pass, and we'll create a node. So when we'll come to the list node, right, what we need to do, we have to pair candidate, we have to define the left node, right node, and the sum. So this is a pair candidate that will have the left node, right node, and you have the sum. So this sum is cast sum, which is used for validation only, and when we want to create a pair candidate, you have to pass two node, left and right node, and the sum. So you will be able to create the node, right? When you come to the comparing, so compare to method will use for the comparing the two objects. So you will check the current sum is not equal to the other sum. Then we will return the long.compare, will compare with this sum after if it is not equal, and then it will obviously it will give the false, right? There is a tiebreaker thing we have to provide, like or the original index for both, and that will return the compare to. Okay, now coming back to the solution, we have a priority queue, min heap, and like that we will create the min heap. Now you have the isMerge method where we will track whether a node has already been merged, means that is called lazy deletion. And then we have inversion count. So this is what we check the number of decreasing adjacent pair, and then operations we will use, and this operation will we will track. Okay, so very first we will build the linked list, right? We will use the heap, and there is head, and there is a current. So we'll start the head and current from the very first node, right? And we'll provide the value. So you know how to define, how to create a list node. So this is the value of the node and this is 0, right, as a node value. And then we'll create a current. So current will create on the head itself, and then we will iterate over the element, given element. So we'll keep adding the new node, and you will create a current, and next, so new node you will add, and the current you will find from the current, right? So like that you will say this is our previous and this is our next node, a new node you can say. You have to add the pairs on the heap, right? So keep adding the adjacent pair to the heap like this. So very first, for the pair candidate, you know that we have to pass the current pair left and right, and then we will use their values as a sum. Now for the initial inversion count, right, what we need to do, we will check if it is greater than, right, it means it's a ascending order, non-decreasing order, right? And so we'll say okay, inversion count is plus plus. Then you will say okay, current equal to new node, we will update like this, and then it will be merged. Now we will check that continue until array becomes non-decreasing. If inversion count is greater than 0, means we need to pull from the heap, that is our candidate. You will check the left and right one. Now for the lazy deletion, either node already merged or not, or some will take like this. So we'll check if it is merged, we'll check the indexes, these indexes has been merged or not. If it is merged, right, and the sum is any of these condition matches, will continue if it is already merged. Otherwise what we will do, we'll do operation plus plus, and then we'll check if the left is greater than right. It means we have to remove the inversion between left and right, and we'll do minus minus. Okay, then we'll check the previous node and next node, and we'll check okay, what is the long merge is here, right value, long merge value, that value will cut from the sum, right, like that will jump. Then we will relink after the merge. So after the what we need to do, left dot next, we'll use the next node, and we'll left node is not equal to null, we'll set the value previous equal to left, and then we will relink. So this is very important for the merging, guys. Okay, after the merge you have to also reset the value. Okay, then we will check the previous not equal to null, means we want to handle the inversion changes with the previous neighbor, and so we'll use the old inversion that has been removed or not. So we'll check okay, previous value is greater than value, and then previous value is less than merge value, so we'll decrease the count. If there is any new inversion is there, means this condition will get satisfied, means the value is greater than the merge value and it is less than equal to the left value. Okay, it means we have to count, right, increase the count. Again you will add the new pair adjacent like this, and the previous node left, previous node value plus 1, like this we have to add on to the pair. Then we have to handle the inversion changes with the next neighbor, that because we have already changed. We'll check okay, the new node is null, not null, it means old inversion removed, right? So we'll remove minus minus, new inversion came, so we'll say plus plus, and then we'll add a new pair on the adjacent pair will add onto the heap. And finally we will merge the thing like left value equal to the merged value, and is merged we have to update as true, and finally your operation will be returned here. So I'll put this code into the comment box. Make sure that you will debug this code by yourself and do hands-on, so you can get the code from the comment box, guys. I'll directly put there, so it will take time to adapt. So what you need to do, use your Eclipse or any IntelliJ or any code editors, and then try to do the debugging. Use these test cases that we have given, guys, and give little thumbs hands-on. So we'll try with the example 1, 2, and there is another test cases that we have. So when you will submit the code, right, you know that these test cases will come. So test case 1, test case 2, and test case 3, right? Make sure that you will use these test cases for the debugging process. then you will understand this code. Okay, so I'm closing the here, and if you want to join our online classes, please ping me in the comment box, or you can directly call my WhatsApp number, you can get from the description. And that's all I have in this video, guys. So in case you are struggling with anything else like Java development on any other technology, let me know in the comment section also, or on the WhatsApp. Okay, so this code is the main logic that we have seen in this code, guys. It's not a very tough thing that we have seen here, right? Very first is that now we want to repeat while there is at least one inversion, right? And each step will give you like we have to extract the minimum sum adjacent pair from the heap, right? Then we will ignore if it's outdated, means that is called lazy deletion, it will go, right? And then we'll merge the pair, right? When we merge, we have to remove the inversion between the two nodes. We update the inversion with the left neighbor, and we will update the inversion with the right neighbor, means both neighbor we have to update. And crucial thing that all the inversion updates are done in O of one time, because we have seen that here somewhere we will see, right? Like that we have to do. So both things we have to do by the previous neighbors and the next neighbors we have to do, right? So there is question that you will say, why the lazy deletion you are doing, right? So because lazy deletion, the heap still contains pair with that reference node already merged, right? So we have to do the lazy deletion, guys, right? And so before merging, we check has either node has already been merged, right? Does the stored sum still match the current sum, right? If it is that, if no, we skip it, right? That is why it works. So why this code will work? We never stop early, we never miss force merges, and we never rescan the array. So the moment inversion count reaches 0, the array is guaranteed to be non-decreasing, and then we'll know that our operations should be returned, and so we'll return the operations. Okay, in case if you are struggling with anything else, please ping me in the comment box and I'll see you in the next one. Thank you. Bye bye.